Let's do Leetcode 209, minimum size subarray sum. This was yesterday's Leetcode daily. Given an array of positive integer nums and positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. So in the example they give us, we have a list or an array of 6 numbers, and the target is 7, and the output is 2, meaning the minimal length of the subarray is 2. And we can see that this 4 and 3 at the end is the smallest subarray that gets you to 7. So the question specifies that all the integers in the list are positive, so we don't have to worry about negative numbers. What this means is that for any subarray, adding any additional element to that subarray will increase the total sum. So for any subarray of the array, adding any other element to it will increase the total. It won't decrease it. So one way we could find the minimal sum is by checking every single subarray and seeing if the sum is greater than or equal to target. So to visualize, we would start at 2 by itself, then 2 and 3, 2, 3, 1, 2, 3, 1, 2, 1, 4, and 3, then start again with 3 on its own, then 3 and 1, 3, 1, 2, going through, and repeat that pattern, 1 on its own, 1 and 2 together, 1, 2, 4, 1, 2, 3. So let's code up this brute force solution. So let's actually start by returning 0 if there is no such subarray that works. So I pointed out earlier that it's significant that the array of integers is positive. What this means is that every additional integer is going to, that we add to a subarray, is going to increase the total, meaning the entire array is the highest total that is possible. So with this array, it totals up to 15, and any chunk of that is going to be less than 15, taking out any number. So if the sum of nums is less than target, then we know that no subarray exists that is greater than or equal to target, and we can instantly return 0. Now otherwise, we can set the answer at the highest possible answer, which is the entire list, the length of the list. Then for I in range, length of nums, and for j in range, starting at I and going to length of nums, we can check if the sum of the subarray from I to j plus 1, remember that this number is included in the subarray, this index, but this index is not included, so it's 1 less. So for example, this wouldn't get the 2 on its own in that first go around. So if all that is greater than or equal to the target, we can update our answer with the minimum of the existing answer, or j minus I plus 1. And after looping through every possible subarray, we can return the answer. And as you can see, this works, but it's very inefficient. We have 2 for loops, which might point out to you that it's n squared in time complexity, but also remember that the sum function is O of n in calculating the sum of the list. So it's actually O cubed. So we can actually make this a bit more efficient while sticking with the 2 for loops just by taking out the sum calculation. So we can make a variable subarray sum and set it equal to 0. And then at every I, we can reset it to 0. So actually we don't even need it right here. And then we can add in j. And you see that that also works, but running this solution is going to give us time limit exceeded because it's too slow. And as you can see, we get time limit exceeded because for very big inputs, it's too slow. So let's go back to the drawing board and find a faster solution. And the optimal linear solution in this case is going to include sliding window, the sliding window pattern. So what we can do is get 2 pointers, left and right, and what we can do is create a subarray that moves through the list and finds the minimal length and returns it. So the way this might work, let's imagine we start the both pointers at this first index at 2 in the sum, subarray sum. Let's get a new color here. Subarray sum is going to be 2. But we know that 2 is less than 7, so we increase the right pointer to 3 to add another element or another number. Now the sum is going to be 5. 5 is still less than 7, so we can move the right pointer. The sum is going to be 6, 2 plus 3 plus 1, still less than 7. Move the right pointer again. Now the sum is going to be 8, which is greater than 7. So we can update our answer. If we'd set it previously at the length, which was 6, we can now update it to the new length, which is 4. And now we can see if we can optimize the length. So we can move the left pointer up to decrease it. And we can recalculate the subarray sum. Now it's back to 6, which is less than 7, so we need to add another element. So we shift over that right pointer. Now the subarray sum is 10, which is greater than 7, so it works. We can update the answer. It's going to stay at 4. We can decrease the length by moving up left. Now the subarray sum is 7, which works. We can update the answer again from 4. Now it's going to be 3. 1, 2, 3. So we can update the right pointer once more. The subarray sum is going to be 10. Update our answer. Move up our left pointer. Our subarray sum is 9. This also works. Update our answer. It's still going to be 3. We move up our left pointer again. Update our answer. It's going to be 2 because it's just these two numbers, 4 and 3, which we know is actually the final optimal answer. Now we still move the left pointer over 1 because the target is still equal to, or the sum is equal to the target. Three is less than 7, so we want to move the right. But at this point, right is out of bounds, and we want to stop the program and return our answer. So let's see how this looks coded up. So let's code up our sliding window approach. We can leave in the if statement to check if there's no possible subarray. We can also leave in setting the answer to the length of the entire array, because this is the highest possible answer, and we know that if this passes this if statement, there is some answer to return. We'll set our left and right pointers equal to 0. This is actually too fancy for my taste, so I'm going to put it on separate lines. And we also want to make a subarray sum variable, and we're going to set it to, we could just set it to 0, but we'll set it to the right pointer. And while the right pointer is less than length of nums, we want to keep expanding our window. So if subarray sum is greater than or equal to target, this is the point where we want to update our answer. Right minus left plus 1. This is just standard in Python for checking the length of subarray. And here we can also increment the left and see if the sum still is greater than or equal to the target. So we'll take out whatever the leftmost, whatever number's at the left pointer, and then increase that left pointer. If this is tripping you up, just think about that if left and right are at the same pointer, moving left over 1 will make the sum 0 because you'll have subtracted whatever was left in that subarray. And so this if statement won't get hit if left is greater than the right pointer. And so we don't have to worry about out of bounds. So otherwise, if it's not greater than or equal to the target, we know we need to add elements to the list. So we need to update our right pointer to increase the scope of our subarray. And here we can update our subarray. Now there's actually an edge case where we've incremented our right pointer past the length of nums, so we need to make sure that we're not going to get an index out of bounds. So we can do that same check that we have up here down there. And at this point, if it's gone through the loop, we can return our answer. So it passes all tests, let's submit it. So it passes all tests, let's submit it. And the solution is accepted. Our time complexity is going to simplify to O of n because we have the O of n sum just once, and then going through the entire array will take at most 2n times. So that simplifies down to linear, and our space complexity is going to be constant because we just have pointer variables and subarray sum. If you found this helpful at all, consider subscribing. I'm going to be posting more Leetcode solutions in the future, and I hope to see you in the next one.